Okay, I'm going to talk fast because I know you hate boring math videos. So, this is about inverse functions. I'm going to do the first one for you, and then you're going to be asked to answer the second question. Super easy. To find the inverse, this is just a set of ordered pairs. These fancy braces just means a set of ordered pairs, and you have an xy in each one, right? Xy, xy. So to find the inverse, it's simply just to switch the x and y coordinates. Don't change the signs, just switch. Switch the x and y. For example, the first ordered pair, 1, -3, 1, -3, it will become -3, +1. -3, 1. So you're going to do that with each one of the ordered pairs, and that's it. That'll be the inverse. So that the answer looks like that. And the symbol for the inverse looks like this. If f of x is the original set, then the inverse is f -1x. You don't really do anything with that symbol. That's just the symbol for the answer. Okay, your turn. Find the inverse for number 2. Okay, now you're finding the inverse given the equation. And the steps are still the same. You're going to switch x and y, and then you're going to solve for y. You're going to get y by itself. So when I say switch x and y, I just literally mean to switch places. Leave the numbers in the same place. So that's what it looks like with you switching x and y. Everything else stays the same. Now you're just getting the y by itself, and you're undoing the equation, so you're PEMDAS backwards. So PEMDAS backwards, you need to start with the adding and subtracting. So the opposite of adding 2 is subtracting 2. Now just be careful you don't write this as -2 times x, because we were subtracting 2. So x minus 2. Draw your line if you need to. Then we need to do the multiplying or dividing. The opposite of multiplying by 3 is dividing by 3. So then your final answer is x minus 2 over 3. You probably want to pause the video now and write this example, because you're going to be asked to do this next problem on your own. And there's the fancy symbol there. If you write it, there's your answer, x minus 2 over 3. And there's the symbol for the inverse. Your turn, try number 4. Here's the answer to number 4. And typically the negative on the bottom of a fraction, we just float it out front. It means the same thing. Okay, finding the inverse with the fraction, but it's no big deal. We're still going to do PEMDAS backwards. So we're going to start with the adding and subtracting. And we got the opposite of subtracting 5 is adding 5. So then on the left side you have y plus 5. Okay, we said the opposite, PEMDAS backwards, the opposite of multiplying is dividing. But when you divide by a fraction, you actually multiply by the reciprocal. Remember we did some before Christmas. Copy, change, flip. You're really going to have to flip it. So let's just go ahead and do that. So we're going to multiply by 3 over 2. And since y plus 5 is already over there, I'm going to put parentheses around it. 3 over 2 on this side. No big deal on this side. We can just cross cancel the 3's and the 2's, and what's left is x. Whoops, just noticed I forgot to switch x and y, but no big deal. We can switch it now at this point. So, looks like our final answer is 3 over 2. Remember, I'm going to switch the x and y, and the x becomes a y, and that's the answer. You can make it pretty if you want, put the inverse symbol, but you don't have to. Your turn, try number 8. And there's number 8. Okay, this time I'm going to remember to switch x and y first. So switch the x and y. So that's what it looks like when we do the switch. And PEMDAS backwards, so adding and subtracting first. So on the left side we have x plus 4. and y squared. Okay, we don't have any multiplying and dividing, but the next, going backwards, is exponents, and the opposite of squaring is square root. So square root both sides. And the square root cancels out the square. So your answer looks like that. X plus 4 equals y. Now technically, you can square positives and negatives and get the same answer. So technically we should put plus and minus, although that makes it not a function. We'll talk about that more later. All right, your turn to try number 13. Remember, parentheses come last when you're doing PEMDAS backwards. And for this one, you have to make sure you don't continue your square root over the 3, because when you took the square root first, the 3 wasn't over there. Okay, last two problems. These are easy breezy like the first two. All right, if you have to graph an inverse, you're already given a whole bunch of set of points, so let's find some points on there. Here's a point. There's one. Try to find whole numbers, but you could use fractions, it doesn't matter. So let's write the ordered pairs for those points. Remember, x comes first. So for this point, the x is -2 and the y is 3. And then we have a -1, 0, a 0, -1, so I'm going to just write the ordered pairs for all the points. Okay, so there they are. And remember, if you have a set of ordered pairs, just like on the first slide, if you have a set of ordered pairs, how do you find the inverse? You just switch those ordered pairs. So I'm going to write my new set of ordered pairs over here on this side. So this one, we switch this xy, and it becomes 3, -2. Same thing for the next point. Switch those, 0, -1, and so forth. Okay, there they are, and now we just have to graph it. We'll graph it on this same coordinate plane here. Okay, the first point is 3 on the x, -2 on the y. So 3, -2, point goes right there. I'm just going to follow that with all of these points. So that's what the points look like graphed, and it actually just turns the shape sideways. Looks like that. It's important to note that it makes a reflection across the diagonal line. So if I were to draw a diagonal line right through the origin here, that is the reflection for that graph. For the second graph, if you do the same process, let's say I pick this point right here. I want you to tell me what the inverse of that point is. Okay, I hope you said that the inverse is the red point, 1, -1, because you're switching those two ordered pairs. And that's what the inverse of that graph would look like, a sideways cubic function.